Hello, my peeps. This Algebra Nation video will cover page 129, problem 3, part A and B.
Talking about factoring a little bit. We're going to be working through one practice problem that's got a couple of different parts in terms of factoring some expressions. So let's take a look at this one. In this one it says this A part, what we're going to try to do is factor the entire expression completely. So this first part, this A, we have 18x squared minus 8 that I've rewritten off to the right. So now what I have to ask myself is, for each one of these terms, right, 18x squared and this minus 8, is there a factor that each one of those share? Okay, that's my first step, because maybe I might be able to factor out something, and then I might have to kind of realize a little bit more, what else might be going on. So in this case, it says 18x squared, and I have this 8 right here. Is there a factor that both 18x squared and 8 share? Well, 8, obviously there's no variable, so there's no x that each one of these terms share, but do the coefficients share the 8, which is a constant, and this 18, which is that coefficient, do those share any factors? Well, just by looking at them, I can see that both of these are even numbers, so I know that at very least 2 is going to be a factor of both 18 and 8. So let's see if I factor out a 2, if I can kind of see what else might be going on. Right? So if I factor out a 2, what I'm really doing is dividing 18 by 2. It's almost like I'm doing the opposite of distributing. So 18 divided by 2 is 9. And I can't forget about my x squared, so I still have 9x squared. And I'm going to have, instead of minus 8, what's 8 divided by 2? So I factored out that 2. Well, that's 4. Okay, so now I've done the very first step of factoring this expression, but then is there anything else that I can do now? Well, this might be a little tricky, and this is going to be something that you're going to get the hang of eventually, but we have 9x squared minus 4. What we have to realize is that is the difference of perfect squares. Okay, the difference of perfect squares. Here's what I mean by that. So if I just have my 2 out in front, I'm not going to forget about that. That's still out in front of my expression now. But then now, inside of my parentheses, what I can rewrite 9x squared as is 3x squared. Okay, notice that I can say that this entire term right here, 9x squared, is really 3x to the second power. So 9x squared is a perfect square. What is it a perfect square of? Well, if I take 3x times 3x, that gives me, 3 times 3 is 9, x times x is x squared, that gives me 9x squared. So that is a perfect square. Well, what about 4? Is there anything multiplied by itself that will give me 4? Well, what about 2 times 2? Yes, 2 times 2 gives me 4, so 4 is also a perfect square. Okay, so what I can rewrite this as is, instead of 4, I can rewrite it as 2 squares. 2 squared. So then now what I have is 3x squared minus 2 squared, and that is the difference of perfect squares. And remember, there's going to be a very specific kind of way that we are going to factor the difference of perfect squares. So I'm going to keep my 2 out in front. And then now, the way that I'm going to factor this difference of perfect squares is I'm going to take 3x minus 2, right? So for my 2 perfect squares, I'm going to have 3x and 2. I notice that I see that, right? As that squared and this squared is how I get my 2 terms. So it's 3x minus 2 times 3x plus 2. That's just kind of a rule that we're going to have to know. Right? 3x minus 2 times 3x plus 2. So you have one term that's going to have a subtraction sign, one term that's going to have a plus sign. Then after I've done that, I now know that that is factored completely. I can't do anything else to factor that expression. All right, now let's take a look at B. So again, with B, I'm going to rewrite that as...
I thought he said, let's take a brain break. Because you don't want to be all ratchet like this clown on the EOC. Denied. Didn't get a $3.99. Take away his app for a consequence.
64 x to the 4th, right, minus 49 y squared. All right, so 64x to the fourth minus 49y squared. So the first thing that I'm going to ask myself is, do either one of these coefficients share any factors? Well, 64, that's odd, or that's even. 49 is odd, so I know that 2 isn't a factor of both of them. Well, what about 3 maybe? Well, 64 divided by 3. Nope, that gives me a decimal, so I know that 3 is not a factor of 64. So what I'm going to end up realizing is that no, there aren't any factors that 64 and 49 share. Well, what about our variables? Let's see if they share any variables that we might be able to factor out. Well, this first term only has x's as the variable. The second term only has y's as the variable. So we can't really factor out any of the variables either. So then now it's almost like I've hit a roadblock. But if we remember from that previous example that we just did, we might be able to recognize that this is, again, a difference of perfect squares question. Right? A difference of perfect squares question. Here's what I mean by that. Instead of 64x to the fourth, is there maybe anything that's multiplied by itself that would give me 64x to the fourth? Well, what we might be able to realize is the square root of 64 is 8, and the square root of x to the fourth is x squared. Okay, so really, 64x to the fourth is a perfect square. What perfect square is it? Well, it's x squared, or 8x squared to the second power. Okay, and I can actually check myself on that as well. So if I realize this, that the square root of 64 is 8, the square root of x to the fourth is x squared, that's what I'm left with. I'm left with 8x squared to the second power. Okay, 8x squared to the second power. Then now I'm going to take a look at my second term and see 49y squared. Okay, so 49y squared, let me ask myself, what is the square root of 49? Well, the square root of 49 is 7. And then now, y squared. What's the square root of y squared? Well, if I'm going to take the square root of y squared, what I'm going to be left with is just y. So if I'm factoring this, I know that I can have y, or 7y to the second power. Because if I take 7y to the second power, I'm going to take 7 squared, which is 49, and y squared, which is y squared right there. So I have 8x squared to the second power minus 7y to the second power. And I can again apply my rule for the difference of perfect squares in terms of factoring the difference of perfect squares. So remember, I'm going to have my first term, 8x squared, minus my second term, 7y. The first one is going to be subtraction, which is just the sign that you see. And the second term is going to be addition. So it's going to be 8x squared again, plus 7y. And then that is the entire completely factored form of our original expression. All right? If you have any questions,